So first we're going to be talking about how to use our web portal. So the user can log in here, and once they log in, they'll be able to access creating experiments. So we're going to go through the process of uploading an experiment. So this one is a ball tracking experiment, and we can add a node, and this node is going to be a rover Pi node. So it's going to be the ground robot. So we're going to give it a name that'll be accessible by on the network, robo1, and a container name, cont1. And now if we go back to our source code, we can upload the source.zip and the requirements.txt. So in the requirements file, we can see all of the Python modules that it will need, and we can also put all of our source code into a zip file. So uploading the zip file and now the requirements.txt file, we can upload the experiment to the cluster. Now that it's uploaded, we have all the information, but because it uses a rover, it needs to be authorized by an administrator. So we're an administrator, so we can go through here, and going through the nodes that are on the network, we could see that we have a compute Pi node and a rover Pi node. So back down here in the experiment queue, we can see the ball tracking experiment that we just uploaded, and the administrator can select our Pi4, which is one of the rovers on our network, and start the experiment. So now that it's been started, it will be getting uploaded, and as you can see here, the code has been assigned to our Pi4 as we selected, and after some time it will get deployed. So while that's starting to go, we're going to briefly talk about the smile module. So when the user initially imports it, it's going to automatically call this initialize function, which will create sockets for both the Smile app and any robots that they might be using. And they can also use functions like log, which will report data to the platform, get the experiment ID that they were assigned, and also be able to control the robot hardware functions, like being able to move forward or move backward, move left, right, and turning. But another thing is being able to create a video stream, which our application that we uploaded is going to be using to process imaging. So now we're going to do a quick walkthrough through the application that we uploaded earlier for the OpenCV ball tracking. As we can see, it imports the Smile module to begin with so that they can access the functions, and we're also going to be using CV2 to do our image processing. So it first opens a video capture stream, and we're going to be taking the frames of this video, and as we can see down here in the main loop, we get the new frame every single iteration, and we can get a threshold to identify a certain object on the screen. And depending on the position of that object on the screen, we're going to either turn left, turn right, or move towards it using the Smile module functions for movement. And this is going to be shown in our next demo video. So coming back to the web portal, looking at our experiment, we can see from the standard output log that some of our code has been running and it's been able to successfully start going. So now in this video, we're going to be showing the actual experiment that we just uploaded running in the real world. So basically it's going to turn towards the flashlight and move towards it whenever it's centered in the screen. This is a pretty simple example, but it shows how our platform can be used to put code onto an actual robot application and be easily tested in real life.